Okay, so last section, we talked about areas between curves. So just kind of as a recap, if you have two functions and you want to find the areas between the curves, what you'll do is you take the top function minus the bottom function and integrate that over the region that you're interested in. And the last thing we talked about is, what happens if I don't have something that is a function of x? What if I have, something that is not a function but a relation? Am I stuck there, or can I still find the area between those curves? And the answer is that you can still find the area. So if we have a relation instead of a function, so if whatever we have doesn't pass the vertical line test, we can still find the area. It's going to instead be the integral, over the region that we're interested in, a to b, the right function minus the left function. And now instead of going over the x-axis, we're going to integrate up and down, so it's going to be the y-axis, dy. So let's do an example to kind of show what I'm talking about. So we want to find the area between, the line y is equal to x plus 1, x minus 1, and parabola y squared is equal to 2x plus 6. So let me draw this so we have, some sort of idea what I'm talking about. So I'm going to do two different colors. So we'll do the 1 and 1 here. So x minus 1 is going to look like this. It's going to look like that, kind of. Well, probably I could have drawn it better, but I'm not going to try and perfect it. I'm not great at drawing. And then the parabola looks like this. So this one here is y squared is equal to 2x plus 6. And this one here is y is equal to x minus 1. And what I'm interested in is I'm interested in the area. I'm interested in this area here. So I'm going to erase that because we're going to talk about this for a second. So, if I wanted to do this and I tried to do it, in terms of x, you would immediately see that, I can't, it's not easy for me to do. This y squared is equal to 2x plus 1. This right here, I can't write that, as just something, as y is equal to something in terms of x. I'll have to take the square root, and the question becomes, do I take the positive square root or the negative square root? And that's going to make that just kind of a nightmare to do. And there's an easier way of doing it. So instead of integrating, instead of using vertical rectangles, what I'm going to do instead is I'm going to use horizontal rectangles for the Riemann sum. So it's going to look something like this. So the idea is, instead of integrating along the x-axis, instead of going left to right, I'm really going up and down, making these rectangles. So instead of integrating, dx, I can instead integrate dy. And with that in mind, I'm going to write these two equations in terms of y. So if I look at the line, I'm going to get x is equal to y plus 1. If I look at the parabola, I can write this as x is equal to 1/2 y squared minus 3. So now you see that I can write these in terms of y, and then I can just do an integral, and instead of integrating over x, I integrate over y. So here, red is my right function, blue is my left function. So we'll keep that in mind when we actually write down the integrals. But we need to find a region of integration. So we need to figure out what values of y we're integrating over. So I'm interested in figuring out, where those two things intersect. So I'm going to make a new page, and then we're going to figure that out. So my functions were x is equal to 1/2 y squared minus 3, and x is equal to y plus 1. So in order to figure out what values of y I'm integrating over, I'm going to set these two things equal. So when I do that, I can move everything to one side. I'm going to get 1/2 y squared minus y minus 4 is equal to 0, or y squared minus 2y minus 8 is equal to 0. Factor this, looks like 4 and 2, right? So it's going to be minus 4 plus 2. Sorry, I changed variables there for some reason. These shouldn't be x's, they should be y's. It's important. So when I solve this, I'm going to get y is equal to 4, y is equal to negative 2. So my area then is the integral from negative 2 to 4. So I'm interested in the y values. I'm going to do the right function minus the left function. And so when I plug this in, I already labeled my right and left. So my right function was the line. So it was the y plus 1. I'm going to subtract off the 1/2 y squared minus 3. I'm going to integrate this dy. All right, so I'm going to make a new page. Simplify this a little bit. So this is the integral from negative 2 to 4. So right minus left again. So we're just going to rewrite this y plus 1 minus 1/2 y squared minus 3 dy. So double check something. Sorry, I forgot parentheses on this page. So unfortunately, doing this by recording, I'm going to make mistakes and it's going to be hard for me to catch them. So go back, make sure that you fill in those parentheses. Okay, so let's simplify things. So this is equal to the integral from negative 2 to 4. Y plus 1 minus 1/2 y squared plus 3 dy. So this is the integral from negative 2 to 4. Negative 1/2 y squared plus y, plus y plus 4 dy. And this I can integrate directly. So this is pretty easy to do. Integral of negative 1/2 y squared is negative 1/6 y cubed plus y squared over 2 plus 4y, evaluated from negative 2 to 4. So if I plug this all in, I'm going to get negative 1/6, 4 cubed. So I'll just do every step so we see it. Minus negative 1/6, negative 2 cubed plus 1/2, negative 2 squared plus 4 times negative 2. Okay, so we can go through and simplify this a little bit. This is negative 1/6 times 64 plus 4 squared is 16 divided by 2 is 8 plus 16. And then, so let's see, we have a minus plus minus. We're going to get minus 1/6 times 8. We have minus 4/2 plus 8. When you do all this, assuming I didn't do anything incorrectly, this actually comes out really nicely. It comes out to 18. So this is where, maybe having that non-graphing calculator is beneficial. But so again, it's not too much different from what we've seen before. If you cannot, so if you look back, if you notice that you cannot write, so this I cannot write as y is equal to something, then you're going to, instead of integrating the top minus the bottom, you're going to do right minus left to make y your new variable. So nothing too crazy. So I want to do one more example to finish out this section, maybe one or two more. I'm going to do one more example on this slide, or this set of slides though. So, okay, so let's do an example. Oh, crap. So let me make sure. Okay, so we're good. So we have this example. So let's find area enclosed by y is equal to the square root of x minus 1 and x minus y is equal to 1. Okay, so you look at this and it might seem, you might have a little panic attack at first, thinking that you might have to do what we just did, where instead of integrating, instead of integrating dx, we have to integrate dy. This is not that case though, because this could be rewritten. This one right here can be rewritten. This is y is equal to x minus 1. So if I want to figure out what this, so if I want to do this problem, I'm going to take a look at the graph. So I have square root of x minus 1, so that's going to look, so it is the square root of x shifted 1 to the right. It's going to look something like this. And then the line x minus 1, so that's either shifted to the right one or down one. So that's this one. Okay, so this is, it's, you might have to zoom in if that's a feature on YouTube, I'm not sure. That's the area we're looking for. So really what we're going to do, and just break it down into steps. So we're going to do, what we're going to end up doing is the integral a to b, top minus bottom, dx. So you can already see what our top function is. Our top function is the square root 1. As the first one I drew, the bottom is the line then. So the last thing we need to do is we need to figure out what a and b are, what our area of integration is. So to do that, we're going to find integration bounds. We're going to set the functions equal to each other. So when I do that, I'm going to get the square root of x minus 1 equal to x minus 1. So what we need to do here is we need to square both sides. Yeah, so let's square both sides. I'm going to get x minus 1 is equal to x squared minus 2x plus 1. And then just go through and we're going to set it equal to 0. So we're going to get x squared minus 3x plus 2 is equal to 0. And then what this ends up going to is what this ends up factoring as. I'm going to have to click a new page. So this is going to be x minus 2, x minus 1 is equal to 0. I'm going to get x is equal to 2, x is equal to 1 as my intersection points. So you can tell that it already happens at 1. The other place it happens is at 2. So now I'm just going to do this integral. So I have the integral from 1 to 2, top minus bottom, dx equal to the integral from 1 to 2. Square root is the top function, square root of x minus 1. And I'm going to subtract off the bottom function, which was x minus 1, dx. So then this is equal to the integral from 1 to 2 This is equal to the integral from 1 to 2. I'm going to split it up. Square root of x minus 1 dx minus the integral from 1 to 2 x minus 1 dx. The reason I split this up is because we're going to have to do a u substitution on the first one. Second one's pretty easy though. So let's break this up into two integrals. So the integral from 1 to 2 square root of x minus 1 dx. This is a u substitution because I can't integrate this when it's shifted like this. I'm gonna let u equal x minus 1. That way du is equal to dx. So this is a pretty easy u substitution. So then I'm gonna get the integral. So when I plug in x equals 1 in for u, I'm gonna get 0, 1 minus 1. When I plug in 2 in for x and u, I'm gonna get 1. So this is now the integral from 0 to 1, square root of u du. So now this is then, so this is u to the 1/2, so it's u to the 3/2 divided by 3/2, evaluated from 0 to 1. So I'm breaking this up just to make some of the math easier. So then this is 1 to the 3/2 over 3/2 minus 0. So this ends up being 2/3 here. For the second one, so we have the integral from 1 to 2, x minus 1 dx. This one's a little easier to do. We can do this directly, x squared over 2 minus x evaluated from 1 to 2. And when I do that, I'm going to get, so when I plug in 2, I get 4 divided by 2 minus 2. When I plug in 1, I'm going to get 1/2 minus 1. This is 2 minus 2, which is 0, minus 1/2 plus 1. So this is 1/2. So my final answer then is square root integral minus that integral. So it's going to be 2/3. Sorry, it's going to be, so my area then is 2/3 minus 1/2. So 2, 4, 3, I think is a 1/6. So you'll need to check me on that. I don't have a calculator in front of me, and it's like 10 o'clock at night right now, so my brain's not working very well. Yeah, that seems right. So that's that. I think I'm going to stop here. Definitely going to stop here. I don't think I'm going to do any more examples for this. So my plan, I haven't said this, I'm going to send it down in the email, but my plan is to, so I will do these, lectures and have them posted at the beginning of the week. My plan is to write up some examples for you. I'll do some recordings with some examples for Fridays, kind of like you had if you had a recitation. So here I'm doing examples from the book and going over the material from the book, but I also like to do some examples like a recitation. So if you have problems you want to see, you're welcome to send them in to me for Fridays. I'll post a video on my YouTube channel so that you can see those examples. If you don't have questions, I'll pick some to do that I think are relevant. You're welcome to watch me do them. I guess I can see how many views I have on the YouTube video. So I don't know. It'll be interesting to see if people are watching this or not, but hopefully you guys find it helpful. So I'm going to move on to section 6.2, leave this here. All right.